guys are staying warm, having a great time this week. I did make it to the movies this weekend. I went and saw. Is this thing on? It's a. It's. I don't know if you call it a romance, a drama, or what. It's not even really a comedy. I don't know what it's called. But it's got Will Arnett, and it's about a couple in their relationship. They've been married for a while. They got kids, and they're just kind of things just aren't great with the relationship. It's I mean, no one's having an affair or anything. It's just they're and they kind of split up, and he decides he goes to this bar and they have an open mic night like for comedy. So he gets up there and says, I'll try it, and he does like 10 minutes, and a few people laugh. He's just talking about his marriage, and so he starts doing that regularly and starts hanging out with the comedians, and it ends up kind of like therapy for him because he gets up there and talks about what's going on in his life with his marriage and all that stuff, and some of it's funny. People laugh, and so the whole thing's really weird. I mean, the first hour, it's a 2 hour movie. In the first hour, I'm like, oh my gosh, I'm going to fall asleep. This movie's moving so slow and it's so boring. But then at the end of the movie, I got up to walk out of the theater and I went, hey, I like that. It was good. So it redeemed itself by the end. It turned into where, okay, it all kind of pulled together. At the end, you're like, I'm satisfied with the ending, which I thought I was going to hate the movie. Halfway through it, I'm like, oh, this movie's just going to be terrible. I'm going to walk out of regretting I came to see it. But somehow, I can't even figure out really how. Somehow at the end, I felt satisfied. It was a good movie. So there you go. There's this thing on. Will Arnett. So I saw it mainly because I like Will Arnett. He's a funny guy. But all right. Well, let's see if we can find anything in Buzz to do this week. We're actually going to start our Buzz curriculum this week. Last week was just kind of a hey, welcome back from the semester. We're here, yay! But no, let's actually get into some good stuff this week, and we have a pretty cool list. We're gonna start getting into some more commands, which I know Vivian, you've done enough Python research on your own. You may already know all this stuff, but this is pretty cool compared to what we learned in programming one. We're getting some cooler stuff this week, and I've already looked ahead to the first program I'm going to write, and I'm pretty excited about that. But we're not there yet. It's not now. Let's go to our grade screen just to check in. So we have functions, 4.01 functions this week. And we're just doing one lesson a week here, starting with 4.0. I think we may not have a program till 4.04. I think we go 3 weeks before we have a program, if I remember correctly. So it'll kind of get us going in here. But there's some good stuff in this first lesson. So let's open up our folder. You can look at this changing the world with data, but it basically is just summarizing the whole unit. It just talks about how long each lesson should take. Think about 60 minutes. It's worth 25 points. And that means 60 minutes means if you went through the whole lesson, read everything, then did all the questions afterwards, it shouldn't take more than, actually, it won't even take 60 minutes, but most of these are 60 minutes, 60 minutes, 90 minutes, because this is the one where you actually write a program, 4.04. That's worth 100 points, the data exercise. We don't write a program for the first 3 lessons. We just have the 5 question quizzes. But that's all there is on this first changing data. It just summarizes the unit, lets you know. I left it on there just because. Let's look at 4.01 functions. Again, I'm pretty excited about our stuff we're learning here. Code like the pros. Oh, you betcha. We code like the pros. No one likes waiting for something to load, whether it's a website, an app, a program, anything else. Here's something else no one likes: data overage limits. Now, you don't see that as much anymore, but there's still some cell phone plans out there where you only get so much data, and if you use over that, you get charged extra. Or there's even some home internet plans that are like that you're given so many gig. If nobody likes to have to pay for data overage. But thankfully, Python's got important tools like functions that can help solve these issues. It's as simple as using memory efficiently and focusing on reducing the amount of data you need. Memory matters. Every function, every variable, every procedure adds to a program's memory bill, uses more memory. Programmers consider all these small details when they code to create efficient programs. So here's some strategies you can use to streamline and make it easier to work with data. An efficiency cheat sheet. Built-in is better. Like, don't rewrite history. Use Python's built-in functions when possible. That's what they're there for. Like, print is a built-in function. There's probably a whole lot that goes on to actually print and put something on the screen. We do it with just one command, print. So all that behind the scene stuff, we don't have to worry about. Less is more. Variables can increase a program's memory drastically. Saving stuff and keeping that variable the whole time uses up memory. Yes, Vivian.
So for your less is better one, would that be like C++ because like it uses so many things just to print something?
Yeah.
What?
So, but yeah. So, a lot of these built-in functions can save a lot of that memory that doesn't take much to do. So with variables, only use those when you really need to. I mean, I've had some people that use a variable one time. I was like, variable equals 17, and then they said total equals variable times something. It's like, you didn't need to store that 17 as a variable because you just used it in one line. You just could have put the 17 in that line instead of making it a variable and printing the variable. That just, clogs up some memory and keeps it the entire time the program runs when you only used it once. So maybe you don't need a variable in that case. Think modularly. Try to hit a sweet spot where sections of code are small enough to be reused, but not so small that they're not useful. Like writing a separate function over something that you're going to do over and over again, so you can just call that function however many times you need to, instead of rewriting that code multiple times. So think of just writing a modular way where it's just a little function that is reused. Readability counts. Use the pound symbol to make lots of comments so you can keep track of each section and its purpose. So that kind of helps you not repeat a bunch of stuff. And simplicity is everything. Remember to KISS. Keep it simple, smarty pants. I've never heard the smarty pants edition on that, but I like it. If it's difficult to explain, it's probably difficult to code. So try to keep your programs simple. Just do what they need to do. Don't make it real fancy because you're probably using up a lot of memory. Oh, here's a really cool thing. If you didn't know about this Easter egg, you know what an Easter egg is. It's something hidden in there that you can't find in the directions. Nobody tells you it's there. You have to know. You have to know somebody, like a programmer. Python has some of that. Import this. This is a little Easter egg known as the Zen of Python. There's 19 principles, software principles, that influence the design of Python programming that the writers of Python hid in the code. Many of them offer advice on coding efficiency. So let's take a look at this. If we open up an idle window, all right, and we're going to say import this. That's our whole command, import this. Look what it produces when we run. Here's a poem that produces, by just import this, The Zen of Python by Tim Peters. Beautiful is better than ugly. Explicit is better than implicit. Simple is better than complex. So, make your code simple. Complex is better than complicated. Flat is better than nested. Don't nest code unless it needs to be nested. Sparse is better than dense. Readability counts. Special cases aren't special enough to break the rules. Although practicality beats purity. Errors should never pass silently unless they're explicitly silenced, because you can silence errors. In the face of ambiguity, refuse the temptation to guess. There should be one, and preferably only one, obvious way to do it. Although that way may not be obvious at first unless you're Dutch. I don't get that. That's probably an inside joke. I don't know. Now is better than never, although never is often better than right now. If the implementation is hard to explain, it's a bad idea. If the implementation is easy to explain, it may be a good idea. And namespaces are one honking great idea. Let's do more of those. So that's a little hidden Easter egg in Python that if you type import this, the writers have hidden these little tips on developing Python code. I thought that was pretty cool. Yeah, Vivian.
Is that just in the Buzz idle?
I don't
Or
know. I haven't tried it in another writer. It'd be interesting to try. It's probably in all of them. I would guess it's probably a very, very basic low-level command that's hidden in there. If you just say import this, I bet it works in a lot of them. In fact, that's a good question. Let's just pull up a Python emulator on the. Let's just type Python. See if we welcome to python.org. Let's just go to the actual python.org. Let's see. Oh, we got to download the source code on this one. Let's do a Python emulator to where it's all on a website. Yeah, you got one that's good?
Yeah, so let me see if I can do it on my computer real quick. I have it on my other one. I know I did it when I was in person doing coding class.
Okay. Here's one at programiz.com, but yeah.
Yeah, it looks like that. I don't think it's on this computer. I forget what it's called, but let me go into it real quick. I mean, it might work there.
Oh, here it is on this one. Import this. It thought for a few seconds and then pulled it in.
I love it.
So it may be in all of them, because this is just a Python emulator I found online at programiz.com, and it's there. So that's kind of cool. Cool that you can find it anywhere. So yeah, when you get yours, see if it works on yours that you've got saved on the computer there. But just pulling up a different Python emulator. Love the little Easter eggs hidden in things. Excel's got some pretty good Easter eggs hidden in Microsoft Excel even. All right, let's go to page 2. Return statements. So in a food truck, a cashier can only process one order at a time. They take the order, they give you a total, they take the payment, cash it out. So to keep track, the cashier submits orders one by one and passes them on to the cook. Here, we need a chili dog or whatever. In a program, using return is similar. Submitted in orders like calling a function. Call a function and run the code. The return happens when the cook receives the order, but this only happens after an order is submitted. Once you send the order, then the cook can return the food. If the order is never submitted, the cook won't make the food. You'll be hangry. In other words, the program's got a bug, right? Never got anything back. So using return statements and functions. When defining a function, you can specify what the return value should be with a return statement. I know we've done separate functions that just does something. Call another function, that function just does something, whatever it does. But you can have it return specific stuff. A return statement consists of the return keyword, so that's a key code word, return, and then whatever value or expression it should return. And we're going to look at a great example of one here in a minute. By using return statements, you can use functions to produce values. But how does it work? Well, calling return at the end of a function tells that function to stop what it's doing and send this value back to whatever called the function, which is usually another function or the main function or some function. This allows you to write functions that are incredibly useful, especially when working with large amounts of data. So this program uses the random module to return one of 4 different string values. So every time it runs, the program execution returns to line 15 where Magic 8 Ball is called. So let's copy this into our code. So this is basically a program that acts like that little toy, the Magic 8 Ball. I'm going to import this with this new code. First, look at this. The first thing it does is import the random function. So it's able to randomly select numbers. We define the Magic 8 Ball function. And we do have an argument that we send it. We send it the answer. Send the answer. And if the answer is 1, if that's what it gets, if it equals 1, it stops right there and returns it is certain. But if it's a 2, it returns does not look like it. If it's a 3, it returns yes. If it's a 4, it returns ask again later. And you know, the Magic 8 Ball, I think, has more options that you can make this bigger, but this is just returning different things from this function. So then the main function, what it does is it has a variable it just calls t, and it chooses a random integer between 1 and 4, 1, 2, 3, or 4. And it sets that equal to guessing. Guessing will equal whatever the Magic 8 Ball function is when we send it this number. See, we're going to send it that 1, 2, 3, or 4 up here. Up here, it's going to say, okay, what is it? Is it a 1, 2, 3, or 4? And it'll return this. And whatever it returns, we're going to save that as guessing and then print it. So let's run this. It is certain. So apparently when we ran the program this time, the integer ended up a 1. So we sent that 1 up here to the Magic 8 Ball function. And it says, oh, since it's a 1, I will return this value. But it doesn't always return this value. Ask again later. The random integer must have been a 4 that we sent to the function. So the function returns something different every time based on the random number that's sent to it. So that's really cool because before when we worked with functions, they always just did one thing. And whatever that one thing was is what they did. But this one actually does 4 different things. It returns 4 different answers based on what is sent to it. So this return function is really cool, saying, okay, this is what I want you to send back. And so whatever it sends back, we save it. I want to keep what it sends back to me, and I want to print that. So that's a pretty neat little program. So let's see. We ran that. Let's go page 3. Defining functions. So have you ever had to write an essay that had strict formatting guidelines? Got to be 5 paragraphs. It's got to be 2 pages. It's got to be double spaced. It's got to be size 12 font. I've been there, done that. I remember having one of those, had to have a 10-page research paper in my junior year of high school. I had to have all these stuff. So when your teacher calls the function, essay, parentheses, proper format, they're expecting certain parameters. Let's talk about what a parameter is. This is a variable in a function definition that specifies an argument that function can accept. Like, and then what we saw on that was the P, whatever the number, that function accepted a number so it could check to see which random answer to return. You must pass your written essay or argument. This is the value passed to the function. Now, T is the T has to be a number. That's the value passed. The parameter was it has to be, T, but the argument was the actual number it sent in the proper format for its value to be accepted. It's important to remember that parameters and arguments are related, but they're not exactly the same thing. A parameter is a variable within a function definition. Like in this case, it was T. It has to be T. An argument is the actual value passed to the function when it's called. So I sent a 3. That's what T equaled when I sent it. Programmers use parameters to tell a function what type of arguments or values to accept. So let's see how this works in code. We've got a few different examples here. Functions with parameters and arguments. Define main. And now look, we don't often do this with our main function, but our main function could have parameters that are sent to it. In this case, name and message is sent. That's the parameters. This has to be a name and a message. This function greets someone with the provided message. And in the main function, it prints hello plus the value of name and the value of the message with a comma in between them. So when we call the main function, we actually are sending it 2 values. We're sending 2 arguments up there. We're sending a name and a message. So when we run this, it says, hello, Jaden, good morning. As we send it the value Jaden, we send it the message good morning. Like I say, we usually send things to other functions, not usually do the main function, but the main function is no different than any other function. You can send arguments using its parameters just like any other function. All right, next. Assigning default values. This is really cool. So we could have this function called welcome, and it receives name and message, just like the last one we looked at, name and message. But look here, we said message equals good morning. Does that mean the message always equals good morning? No, what that means is if you don't send a message, this will be the default value. If you don't send anything, it's automatically going to be good morning. Because look, we're going to call this welcome function twice. We're going to call it twice. The first time, we're just going to send it a name. The second time, we're going to send it a name and a message. So let's run it and see what happens. Oh, the first time the function ran, it printed, hello, Jake, good morning. We did not send a message, but it had a default message already defined. Good morning is the default message. The second time we called the function, we gave it a message. So instead of saying good morning, it used the message that we sent it. Hello, Justine. How are you doing? So that's pretty cool. We can set a default, but you can override the default if you want to send something different. Example of a variable argument length when the exact number of arguments is not known. This is another cool thing too. So again, we're going to use the main function and we put an asterisk in front of names. We put an asterisk for them names. So names is a list. It's a list. And we say, okay, asterisk, this is a list. And we don't know how many we're going to get. Normally, when you send it through your call the function, it'll use it once. So this uses a loop for name in names, and names is the name of the arguments that's sent up here. Print hello name. So when we call the main function, we're sending it 4 different names in quotes with commas separated. So it will actually create a loop to print all 4 of these. Look there. Hello Rita, hello Luke, hello Hassan, hello Kala. And we can just add names on there. Now when we run it, it adds hello Tegan, hello Vivian right there on the end. Because it doesn't care how many we send it. The asterisk says, okay, just whatever you're sending, I'll take them all. Could be 2, could be 20. Asterisk names. So the list is just created right there as it's sent. So that's a pretty cool thing there too. Oh, they wanted to say, change the print statement in the for loop to say good morning instead of hello. Okay. So we can say, good morning. Run. Good morning, Rita. Good morning, Luke. Good morning, Hassan. Good morning, Kala. Good morning, Tegan. Good morning, Vivian. So there we go. It doesn't think that it's correct because I added 2 names it didn't expect to see. All right, let's go to page 4. Classifying functions. Have you ever ordered from a food truck? Then you know there's a lot going on in a little tiny space, right? It's just a little small camper truck. How do they get it all done without losing their minds? Well, that's easy. They break it down into smaller tasks. One person's at the registers, one person making food. There may be someone else that puts it on a plate and gives it to you. They prep food in batches and they assign each employee a job. There's cooking, assembling, cashing out orders. Each of these tasks is a subroutine. It's a section of code that can be reused several times in the same program. It's separate from the main code and must be called. You got to call the subroutine. A programming subroutine might involve looking at a lot of data, whether it's tracking inventories, taking orders, collecting customer information. So in programming, subroutines break a large program down into smaller sections that can be reused. Subroutines themselves are functions that contain other functions, and all functions are classified according to what they do. Functions that return a value and functions that execute a procedure. Is that confusing? Yeah, let's break it down a little bit. Let's look back at this Magic 8-Ball program again. Okay, so this had the main function down here where it chose a random number. It called the Magic 8-Ball function up here. It returned a value and printed it. So looking at this, what are subroutines?
So again, don't think of it like
Both of these functions would be considered subroutines. All right, those are subroutines because they are reusable sections of code that just break down a part of the program. The main, we could call the main several times. We can call Magic 8-Ball several times. Those are subroutines. Now, there's actually 3 functions. There's 3 functions in this code. Magic 8-Ball, main, and print is a function. Print's a function. It's already, all the code of what it does is hidden because it's built in, but it's a function. But it is not a subroutine. This print execution, it's done one thing, guessing. It prints it. So it is a function, but it's not a subroutine. So every time you define a new function, it's really a new subroutine you're creating. All right, return values. The Magic 8-Ball function is a subroutine because you can reuse it. But it's also a function that returns a value. Like if it's a 4, it returns ask again later. It can return different values. Functions that return a value perform a task and return the value back. So that's return values. So this is a function that's a subroutine that returns a value. It could be something like calculating the average age of customers, generating a customer's bill with sales tax, calculate your total weekly sales and revenue. All right, now let's look at procedures. The main function is a subroutine, and because it can be reused, it contains a print function that executes a procedure. Print's not defined on its own, so it's not a subroutine. It's a built-in function. Procedure functions do not return a value. Instead, they execute commands within a program. So that's why this main is considered a procedure, because it executes commands like printing. So generating a database of customer email addresses, printing a menu with prices, displaying current food inventory, all procedures. What about the main function? Functions break up a program into smaller pieces, and the main function is no different. It's often used to provide the main tasks that a program will perform. And although it's not required, your program will run without a main function. You should get in the habit of including that because it's considered best practice as a program. That's why I say every time, make sure you include your main function, because it's a best programming practice, even though Python doesn't care if we have it or not. But it just helps compartmentalize everything and makes it easier to understand. Your argument is invalid. You want to debate somebody and use that because you really sound important and official. Your argument is invalid. Functions, parameters, arguments, return statements. Is your head spinning yet? We've been using a lot of vocabulary. It takes some effort to get all these to work together, but we believe in you. Keep at it. Your functions will be functional. Your parameters will be on point. Your arguments will absolutely be valid. To help you make sense of all, we've done a little self-check here. So let's see how we do in this little 5-question quiz. Blank are named, that's a key, named chunks of code to help you streamline large programs. Would that be arguments, return statements, or functions? Which one of those are named chunks of code that help you streamline large programs? What do you think? You can type it in the chat or turn on your mic. I don't care either one. I'll open up the chat. Functions. All right, you both agree functions? Let's see how we did. Perfect. Yeah, functions can be reused or even reused in different programs, it says. So, all right, great. Blank are the variables within a function definition. Within a function definition. Is that the parameters, the return statements, or the arguments? I think the function definition is kind of the key.
If paid, what's your hourly wage?
Yeah, that should be the parameters. What is defining what parameters it's accepting. That should be right. You got it. Parameters are referred to as the variables that are found in the function definition. Perfect. Blank are actual values passed from the functions called. The parameter, the argument, or the return statements. When you call the function, what are you sending it? Are you sending the parameter, send the argument, send the return statements? Yeah. Yep. Arguments. As long as it meets the parameter, you can send the argument, right? Great job. Arguments are the values actually passed. Okay. Blank can accept any number of parameters, including none. You could send no parameters. Arguments can accept that. Functions can accept that. Return statements can accept that. Return statements of, oh, we got disagreement on this one. Let's read them together. See, return statements can accept any number of parameters, including none, or functions can accept any number of parameters, including none. Oh, I think we're going to go with functions, because think of the main function. Usually we don't put any parameters. Yeah, functions like main may or may not have a parameter in parentheses. Most time it doesn't. All right, functions. Last one. Blank, let your functions return any number of values, including none. That's what you were thinking of, that. Returning number of values, including none. Yeah, that is the return statements for sure. Perfect. There we go. Gave us a little score. In procedural programming, subroutines aren't simply nice to have, they're need to have. The purpose of a subroutine is to organize a program, telling the computer the exact steps to take to reach a desired output. Like, our main can be considered a subroutine, and it tells what we need to do to achieve what we want to get done. Putting it all together, programmers use and write functions all the time, so it's best to get comfortable working with them. So let's put it all together. In this activity, we're going to be defining functions, parameters, arguments, return statements. Let's take a look at this. Oh, I think this is the one I saw was wrong. working with default values. And again, I like this default value thing. I think that could be really useful. So we have a function called welcome, and we send a name and a message to this function. But if we don't send a message, there's a default message. The default message says how many people in your reservation. So then we also have a main function down here. And in our main function, we are calling the welcome function twice. Welcome, welcome. The first time we're just sending a name, which it needs a name and message is optional. The second time we're sending a name and a message. So when we run it, hello, Jake, how many people in your reservation? Because we didn't send a message, so it defaults to this message that's defined in the function. The second time we sent our own message. And so it used ours instead of that. But I love it. Line 5, this function greets the person with the provided message. If the message is not provided, it defaults to how may I help you? No, it does not. It defaults to how many people in your reservation. They got it wrong. They had their code, their comment wrong. So their comment is wrong. But that works well. I like the default value that you can override when you need to, but otherwise just go ahead and have that provided. Here's one where it overrides it. Define student, student name, and student grade. Are they defaulting to a freshman? So if we're just entering a new list of students and they're all freshmen, we just enter the name. So it's going to print this function. This function prints the student name and prints the student grade. And then it returns, but it doesn't return anything because it's going to just print inside the function and then go back to the main function. So now we have a print statement using the default value. If we just send Olivia, and it'll go print that up there. And then if we override the default value, and in our main function, we're going to call that same function and send Ava and say she's a senior. So when we run it using the default value, we just sent Olivia, so it used freshman because we didn't send it any kind of grade. When we override it, Ava, and we said Ava's a senior, not a freshman, so it printed that. Now, I thought this was interesting that they put these 4 statements outside of any function. They are not part of the student function. They're not part of the main function. They could have put them inside the main function just as easily. But since they are first, when Python is going down the list, it says that's a comment, that's a function. Okay, skip all of that. Here's the first thing Python sees to do. Print that. So that's the first thing it does. Then it calls this function up here. Then it prints that, and then it says, okay, there's the main function. Then it runs the main function last. So I thought that was interesting. They chose not to put that inside the function. But that's okay. It works. Restaurant reservation program. Name, and here's a default message in the welcome function. Print hello, whatever their name is, that is sent as an argument, plus a comma and whatever message. Here's another function called food, which uses a list, asterisk foods. It doesn't know how many foods it's going to get, but it uses that list. And it has a loop for food and foods. What would you like to eat? And it'll list the foods. In our main function, define main, we call the welcome function, we call the food function, but we don't send it any parameters. So what happens? Hello, Sam, would you like to reserve a seat? That's what happened when we called the welcome. When we called the food and didn't send any arguments, food didn't print anything. So let's give it some arguments. So if we say, okay, pizza, tacos, burger. Okay, now we're going to call the food function and give it a list of items. What would you like to eat? Pizza? What would you like to eat? Tacos? What would you like to eat? Burger? Because that's what we told it to do. Make a loop. However many times you need to get all the foods and print what would you like to eat with the food's name. All right. And we didn't have to send a message because we were happy with the default message. So we just sent the name Sam. That is it. Cool stuff. All right, let's go see what the assignment is. Following code prints out good world, but you want to say goodbye world. So what do you have to do to make by print in between good and world? How many times can a subroutine be used? Love it. Review the code, select the response that's a subroutine. Which one of these things is a subroutine? Add to pizza, item, order pizza, or price. Which statement's always true about the main function? Select the missing line, the correct line of missing code to output hello and none. And that's it. 5 questions. 5-question quiz this week. 5-question quiz. Like I say, it's like we got like 3 weeks before we have an actual program, but we're learning some really cool stuff in the meantime. Being able to send arguments, being able to set a default argument for a function to where don't have to send a function, an argument if we don't want to, because it's got a default, but we can override it if we choose. Lots of cool stuff with this. So I've already looked at the program we're going to have in 3 weeks, and I'm pretty excited about that one too, because we're going to use a database. Our program's going to call a database and pull information out of it. That's a big part of actual real life programming. Like if you're working for a company, a lot of times you have a database, which is your customer list or your orders, and your program will go pull information from that. If you're looking up a customer, when they type in, what's your account number? You type in the account number, it goes to a database, checks that account number, and pulls back, oh, here's the customer's name, address, and all that information, phone number. So that's the type of stuff we're going to look at with this program. Very excited about it. So, all right. That's it for today. We'll let you go have a great week. If I see you again, fabulous. We'll have class on Wednesday, but it's optional. We're to our normal schedule. So it's optional. If you're having problems, come see me. Otherwise, I won't see you till next week, or if I have you in math. So